Welcome to another um, chapter in our physics 102, which is electromagnetism. So, we are on a series called electromagnetism, or in most schools, it is called physics 102. And this is the second chapter under the series. The first one is electrostatics. We discussed that in the previous video, so you can watch the previous video to understand electrostatics. And do not forget to subscribe, like, and share. So now let's start with this this one. So today we'll be discussing electric field strength, direction of electric field, properties of electric field. We will now understand what is dipole and torque. Now, so let's start with electric field. Um, what surround a charge is called electric field. For example, what surround a mass is called gravitational field. So in the same way, what surround a charge is called electric field. But the correct definition of electric field is that electric field is the region of space around a charge where the electrostatic force of that charge can be felt. That's electric field. Now, each point in this electric field have what is called electric field strength, or we can call it electric field intensity. Meaning, if I have a charge, for example, this is a charge, what surrounds this charge is called what? The electric field of this charge. Are you seeing it? Now, each point in this field possesses different strength. Meaning the strength of the field at this point is different from the strength of the field at this point. The strength of the field at this point is different from the strength of the field at this point. It is only when the field is uniform, that is when the strength is the same. But in a non-uniform field, the different points in the field possess different electric strength. So this chapter is dedicated on allowing us to calculate the strength of the field at a particular point. So what we want to discuss today, we want to look at how do we calculate the strength of a field at a particular point in an electric field. Are you getting it? For example, if you're asked, what is the strength of the field at this point? We should be able to calculate it. What is the strength of the field at this point? We should be able to calculate it. What is the strength of the field at this point? We should be able to calculate it. You get. So what is electric field strength or electric field intensity? Electric field strength or intensity at a given point in an electric field is the force per unit charge at that same point. Meaning, electric field intensity E is equals to force per unit charge, where this E represents electric field intensity. Why? And hold on, the unit of electric field intensity is Newton per coulombs. Why? Our F, as we all know, F represents force, wherein the unit is Newton, and we know that Q will represent the word charge. But in most cases, we do write this formula in a beautiful way, meaning if you cross multiply, you now have that word F is equals to QE. So any way you want to write this formula, you are still correct. So the force per unit charge at a particular point in an electric field is called the electric field strength. So is that clear? All right, now let's look at the direction of electric field. Now you must understand that electric field intensity is a vector quantity, and what you must understand about vector quantity is that for you to specify a vector quantity correctly, you need both the magnitude and the direction. Is that clear? So because electric field strength is a vector quantity, we need both magnitude and direction. Let's look at how to get the direction. Now you must understand that basically we know that there are two types of charge, right? There is the positive charge and there is the negative charge. So we have the positive charge and we have the negative charge. And in our previous video, I told you that if positive charges are created as a result of deficiency in electron, while negative charges they are created as a result of excess or surplus electron. So you must have in mind that both the positive and the negative charge both are as a result of the electron. In fact, basically, charges are as a result of the electron. So if I have positive charge, it means that there is deficiency in electron in that material. If I have a negative charge, it means there is excess or surplus electron in that material. So is that clear? So there are two types of charge, the positive and the negative. The positive charge creates a kind of field that radiates outward, So you must understand that if the charge is positive, the field is actually outward. While if the charge is negative, the field is actually inward. So please take note, do not forget this, that a positive charge creates a field that radiates outward, and a negative charge creates a field that radiates inward. Meaning, if we have a charge, for example, negative charge, you know what surround the charge will be an electric field, right? And I want to look at the strength of the field at this particular point. You get, we have to, for you to get the direction, you have to draw a line from the charge to that point. Because it is negative, the direction will be what? Inward. Similarly, if you have a positive charge, you have a field, right? Then you want to calculate the strength of the field at this point. What do? You draw a line from the charge to the point. Because it is positive, it creates a field that radiates outward. Meaning, you must understand this direction very well because we'll be using it in the calculation that if the charge is positive, you get, how do you get the direction? You draw a line from your charge to the point where you are calculating the field from, you get. If the charge is not positive, the field or the direction will be away from the positive charge. Why, if the charge is negative, it will be into the negative charge. So you must have this in mind that a positive charge creates a field that radiates outward, while a negative charge creates a field that radiates inward. Exactly. So if we let's break this down. We know that according to Coulomb's law, right? Recall, hope you have not forgotten in our first course, according to Coulomb's law, F is actually equals to K, Q1, Q2 over R squared. You get? So if I replace F in this formula with this, I'm having something, this Q will cancel Q, so it means E becomes K Q over R squared. So two formula you must put in mind, formula number one and formula number two. Is that clear? So E is equal to F over Q. That's the first formula for electric field intensity. The second one is KQ over R squared. Is that clear? Now, so the next thing, let's look at the properties of electric line of force. To actually represent the electric field, we use what is called line of forces. What is line of forces? Line of forces are imaginary lines in which the tangent to it at any point give you the direction of the field. That's line of forces. So there are certain properties of line of force you should be familiar with. Like, for example, line of force do not intersect. So is that clear? So line of forces do not intersect. That's number one. Number two is the tangent at any point gives you the direction of the field. That's number two. So what was the first one? Line of forces can never intersect. The second one, the tangent at any point give you the direction of the field. Number three is that For electric field, line of force originate or start from the positive charge and, and terminate or end at the negative charge. Please have this in mind. Field always move, electric field rather, always move from positive to negative. You can also say it away from the positive charge towards the negative charge. Is that clear? So now, okay, the fourth properties of line of force that you must be familiar with is that the density of the field gives you the strength of the field, meaning the closer the lines, the stronger the field, and the wider the line, the less or the weaker the field, rather. Let's put it that way. So, four properties you must be familiar with in line of force is number one, line of force cannot intersect. Number two, the tangent at any point give you the direction of the field. Number three, the density of the field give you the strength of the field. A closer line of force indicates a stronger electric field, while a wide line of force indicates a weak electric field. And number three, for electric field, line of force always originates from the positive charge and terminates from the negative charge. Now, let's discuss the concept of dipole. Let's discuss the concept of dipole. Now, you must be familiar with the basic concepts in chemistry, right? So we are going to use some chemistry knowledge to actually understand the concept of dipole. Now, let's start. Now, let's take a compound in chemistry which is called HCl. Now, if I ask you the bond in HCl, hope you are not thinking ionic bond. The bond in HCl is what? Covalent bond. And one of the properties of covalent bond that we know is that there is equal sharing of electron. You get? So if I have hydrogen here, I have chlorine here, it means the electron being shared between hydrogen and chlorine will reside at the center of them. It means both of them, there is equal sharing of electron. Are you getting it? That's the properties of covalent bond. But we understand something in chemistry which is called electronegativity, which represent the ability of an atom to attract bonded pair electron to itself, meaning different elements has different ability in which they attract electron to themselves. For example, you know that metals tends to be electronegative, non-metals rather tends to be electronegative elements. Why? Because they have the ability to attract electron to themselves. Why? Metals are electropositive. Are you seeing it? Now, so because of that, between hydrogen and chlorine, you will see that the electronegativity of chlorine is far more greater than that of hydrogen. Meaning chlorine have more tendency to want to attract electron to itself. That's the meaning. So if chlorine has more tendency to want to attract electron to itself, it means that this electron that is being shared, that should be at the center, will be closer to chlorine than it is to hydrogen. Why? Because of the electronegative value of chlorine is high. Meaning the electron that should reside at the center will now be closer to chlorine than it is to hydrogen. Now, it will now look as if, though it's not true, but it will look as if chlorine is accepting electron and hydrogen is losing electron. But is that what is happening? No, because the bond is covalent. So what is happening is sharing of electron. But because of high electronegative value of chlorine, is now looking as if chlorine is accepting, hydrogen is losing. And we know from chemistry, when an atom accepts electron, it becomes negative. But is it really accepting? No, because it's looking as if it's accepting, we put partial negative. You see it? So it will look as if chlorine is losing hydrogen is losing electron. But is hydrogen really losing? Plus, because if you lose electron, it becomes positive. Was hydrogen really losing? No. So we call it what? Partial positive. Are you seeing it? Now, you see now that in a molecule of hydrogen chloride, you now have some ionic character. Are you seeing it? So you now have charge here plus, you have charge here minus. The separation of that charge, D, this is what we now call dipole. So what is a dipole? Dipole is formed when two equal and opposite charge are separated by a distance. Are you seeing it now? So dipole actually form in a molecule when two equal but opposite charge are separated by a distance. And in physics, we are mostly interested in what is called dipole moment. We are interested in the term called dipole moment. And dipole moment is actually the charge multiplied by the distance. And the unit for dipole moment is actually coulombs per meters. Are you seeing it? Now, if a dipole is placed in a uniform electric field, what will happen is that dipole begin to rotate. And we know from rotational motion that the force that is responsible for rotational motion is called what? Torque. Are you getting it? So when a dipole is placed in a uniform electric field, it rotates. And the force responsible for rotational motion is called what? Torque. And in physics, we know that torque, this how to represent torque, is actually equals to force times perpendicular distance from equilibrium of force or from rotational motion, right? So torque is actually force times distance. Is that clear? And do not forget that from this formula of electric field, if you cross multiply, remember I tell you can write this formula beautifully by cross multiplying, which will give you F is equals to QE. It means I can replace this force with this, that I have torque is actually equals to QED. So do not forget this. So what you must remember is that the region of space around a charge where the electrostatic force of the charge can be felt is called electric field. And that the strength of the field at a particular point is called the electric field intensity, which is defined as the force per unit charge at that point. And you must also understand that electric field intensity is a vector quantity. Because it is a vector quantity, it will have both magnitude and direction, you get. And to get the direction is depending on the polarity of the charge. If the charge is positive, it creates a field that moves outward. While if the charge is negative, it creates a field that moves inward. To represent electric field, we use what is called line of forces. And some properties of line of force that you must not forget is that number one, line of force do not intersect. Number two, the density of the line of forces gives you the strength of the field. That is, a closer field indicates a closer line indicates a stronger field, and a wide line indicates a weak field. And you must also understand that electric line of force originates from the positive charge and terminates from the negative charge. So now let's look at some examples.